This video demonstrates the construction, filling, and maintenance of a Johnson-Su bioreactor. This reactor was designed and built by David and Hui-Chin Su Johnson in a project with USDA to develop a method that could easily and effectively compost dairy manure. This type of composting is a static composting process that allows the pile to be undisturbed for the complete duration of the composting process. This lack of disturbance allows the fungal communities to flourish and provides a more optimal process to break down beginning biomass substrates and produce a better quality compost. Besides for producing a more fungally dominant compost, the reactor process had also demonstrated a reduction in product salinity relative to the salinity of the beginning substrate. This reactor is constructed from materials that should be locally available. One pallet with large enough holes cut in it to accommodate standard 4-inch drain fill pipe, one hole in the center, and 5 others centered at approximately 24 inches from the middle, placed every 72 degrees. 3 pieces of woven landscape cloth, 2 that are 6 foot by 6 foot, one with matching holes cut into the cloth for the bottom of the reactor, and one 6 foot by 13 foot landscape cloth for the perimeter of the reactor cage. Also, one wire cage, 5 foot by 12 foot 6 inches, constructed from 6 inch by 6 inch 10 gauge remesh used in concrete construction. As you can see, the 6 foot by 13 foot piece of landscape cloth is folded over both top and bottom and is held in place by sewing the cloth at the top and the bottom of the cage with tie wire or baling wire. When you sew the landscape cloth on, the cage leaves a 6-inch flap on one side so you can cover the seam where the cage is joined. I like to stabilize the pallet by placing brick under the pallet and pre-leveling a platform that will support it. If you have a piece of the pallet that is unsupported, you can put in a brick or pieces of wood to hold that piece of wood in place. I then place a piece of landscape cloth with the holes in it on the pallet. Next, I place the wire cage that has been tied with wire every 6 inches onto the pallet. You can stabilize the cage on the pallet with screws, as shown in this demonstration. I built a metal jig out of rebar to pre-shape the round cage at the top, and also use it to hold the 4-inch drain pipe in place during the filling process. I pre-place the pipe into the holes in the bottom of the pallet. I then come back with tie wire and secure the pipe in their proper place so that they do not move around during the filling process. All material you use in filling this reactor should be pre-processed. Wood chips should be small in size, and most organic matter should be shredded or chipped. Pine cones, needles, seed pods, and tropical leaves should be broken up because they have protective surfaces that are difficult for microbes to access. If you're building by hand, this method to wet the material has worked well for me in the past. Material that is in the water bath is moved to a tilted wheelbarrow to drain. As it is draining, I place new material into the bath. As you can see, I place new material in the water bath. I'll tamp it down, and then I'll spray it to make sure it all gets wet. This also, you're filling up this bath as you do this. If you'd like to inoculate the new material with compost from another reactor, this would be a good place to occasionally put in some finished compost for that inoculation. The original wetted material has drained sufficiently, so I place it in 5-gallon pails to be moved to the reactor for placement. And then I start the process again. As you build the reactor up, I do not pack it, I just let the weight of the material settle the pile. Place the material around the reactor as evenly as you can. I'll usually use about 7 buckets per lift. It's handy to have scaffolding set up around the reactor so it's easier to refill. I do try to even out the placement to make sure the reactor fills correctly. It takes about 3 to 4 hours to fill the reactor. Any plastic that you find as you go along, you can take out. You can also begin to true up the reactor if it begins to tilt or by shaking and pulling on the wire cage. The nice thing about this method to wet the material is that all the sand, gravel, and rock settle to the bottom of the bath. You may occasionally have to remove from the bath with a shovel. This gives you a relatively clean compost product. After the pile is set one day, you can then remove the pipe from the reactor. These pipes are only forms to be used temporarily as you fill the reactor. Once you pull them out, they help keep air passageways through the center of the pile. Be sure and check that no flow path is blocked at the bottom of the pallet. You can clean out below the pallet if necessary. Once you have removed the pipe, you will need to set up an irrigation system. I am using a perimeter spray made of 1/2 inch plastic irrigation tubing with 1/32 inch holes drilled at 4-inch spacing, along with 3 to 4 blue spray emitters. Be sure to secure the 1/2 inch pipe to the reactor and leave enough room to allow the piping to move down as the pile settles. I irrigate once a day for 1 minute, sometimes 2 in the heat of summer. This keeps the pile approximately 60 to 70% moisture content. After this is installed, I cover the reactor by placing the 6 foot by 6 foot top of landscape material on the reactor. I'll then pull the corners and place them between the wire mesh and the landscape cloth to secure it from blowing off. And then let the microbes do their job. I will come back after the thermophilic phase when the pile cools down to less than 80 degrees and place earthworms in the pile to help the composting process.